and if you're in my afternoon class, good afternoon. Welcome to math class. As you know, I am out this week at PSSA, so you will be completing this Ed puzzle to learn the law of large numbers. We're going to start with a review. What is the probability of rolling a number greater than 4 on a number die? So think of the numbers you have on a dice, okay, or on a die. You have 1, 2, 3, 4, 5, and 6. So if we want to roll a number greater than 4, our only options are 5 or 6. Remember, probability is always your favorable over your total. So we have 2 favorable options out of a total of 6. And if we simplify that, we end at 1/3. Like I said, today we're going to learn the law of large numbers. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Taking a look at this week, today we're doing law of large numbers in Ed Puzzle. You do have homework that goes along with today's lesson, so please make sure you complete that. Tomorrow we will do another Ed Puzzle, and then you guys will just have a free day on Friday. I do have a link for homework help if you need that. So what is the difference between theoretical and experimental probability? We've learned both of these, okay? Theoretical probability is your favorable over your total possible outcomes. Experimental probability is very similar, but now it's based off of trials. So it's like the M&M experiment we did. We actually pulled M&Ms out of a bag. So even though there might have been more than one blue M&M, if we only pulled one blue out of our 10 pulls, then we had our favorable over our total in the trial instead of over all of the possible blue M&Ms we could have had. So again, theoretical is predictions based on what should happen according to an experiment's design. So your favorable outcomes over your total possible outcomes. So for flipping a coin, that would be heads and tails, or 50%. Experimental is based on your trials. So it's the number of times an event occurred over the total number of trials. So still tossing a coin, we can still only get heads or tails, but let's say that we did 5 trials, and this was our result. Here, our probability of getting heads is actually only 40% because we only got it 2 out of 5 times. So experimental is based on your actual experiment. Theoretical is based on what should happen due to the total possible outcomes. So let's take a look here and see if we can figure out what kind of probability this is. Watching from a window to see if a car will go straight, right, or left at a stop sign. And you can see we watched, we filled in a table. Go ahead and tell me, would this be theoretical or experimental? This would actually be experimental because we didn't pick numbers ahead of time. We actually did an experiment and took down the data we found out. Let's try another one. Counting vehicles in the parking lot. Here is our data. Is this theoretical or experimental? This one is theoretical. Here we have a set number of our total here. We're just looking at the cars in that parking lot. So we have a possible total outcome, and then we're looking at how many cars out of the total, how many vans out of the total, and how many trucks out of the total. Go ahead and answer this quick check. A bag of marbles has 4 colors, green, blue, red, and orange. 15 trials occur where the marbles are replaced each time, and out of the 15 trials, green is picked 5 times. Would this be an example of experimental or theoretical? This here would be experimental because we're actually doing an experiment. We only have 4 colors, but we're looking at how many trials we are doing. So we're not saying what the experiment is of picking green out of 4 colors, but what it is based on our experiment, our 15 trials. Miss Smith picked her M&Ms from her M&M machine until it was empty. What is the probability of having picked a blue? Is this an example of experimental or theoretical? This is an example of a theoretical probability because she picked all of her M&Ms. So she didn't just do trials, she actually took it out of the total. She used all of the M&Ms. So this would be theoretical. Miss Smith picked her M&Ms from her M&M machine until it was empty. What is the probability of picking a blue? Go ahead and take a second to answer this question. Our answer here is A. So of our blue M&Ms, we had 100. Our total number of M&Ms is 270. 100 divided by 270 is equal to 0.37, which is 37%. Sarah asked 20 students their favorite subject in school. 5 say math, 6 say English, and 9 say art. Is this experimental or theoretical? This is an example of an experimental probability. She had a total number of students that she asked a survey to. So she just picked 20 students. Those were her trials. She did 20 trials. So the law of large numbers. Our law says that experimental probabilities come closer to theoretical probabilities as your number of trials increase. So think practice makes perfect. Theoretical is what you should have, but experimental is what happens when you actually do the experiment. And the more trials you do, the closer you will get to what probabilities you should technically have. So let's see if that's true. Here I have an experiment. If I'm rolling a die, I have 6 possible outcomes. So there is a 16.7% chance that I will roll each number on that die, right? You have an equal amount of opportunity to roll each number. If I do 6 rolls, let's say I get 1 1, no 2s, no 3s, 2 4s, no 5s, and 3 6s. Okay, so my 1 is correct, but none of my other numbers match up. Let's say I increase my experiment to 60 rolls. Now take a look. Now they're starting to get a little bit closer. Let's do 600 rolls. Now they're getting even closer to that 16.7. And let's say I rolled that die 6,000 times. Look at how close these are. Off by 0.2, off by 0.3, off by 0.5, by 0.7, by 0.3. Look at how close they are to the theoretical probability. So again, that law of large numbers states that practice makes perfect. The more trials you do, the closer your experimental probability will be to the theoretical probability. We're going to do a few quick checks to finish up here. The more trials I do, the farther away from the theoretical probability I get. Is this true or false? This is absolutely false. We just looked at that. The more trials you do, the closer to the theoretical probability you get. Practice makes perfect. A deck of 52 cards, and 4 of them are kings. So if you look at a deck of cards, there's 52 of them, 4 cards in there are kings. Ron draws a card and replaces it 20 times. He gets a king 2 times. So what would our experimental and theoretical probabilities be? First, do our experimental probability. Well, if we have our experimental probability, he draws 20 times, and 2 of those times he gets a king. So it's 2 over 20, which is equal to 10%. Theoretical is based, though, on our total versus our possible outcomes. Or excuse me, our favorable over our total outcomes. So here, our theoretical is that there's 4 kings out of 52 total cards. 4 out of 52 is 8%. Let's do another one. A spinner has 4 sections numbered 1 through 4. I spin the spinner 100 times and I land on 1 30 times, on 2 42 times, and on 3 18 times, and on 4 10 times. What is the probability of spinning an even number? Go ahead and figure out the experimental probability of spinning an even number. Well, let's take a look. Our even numbers are 2, which we spun 42 times, and 4, which we spun 10 times. So we had a total of 52 even out of a total 100 spins, which is equal to 52%. Now see if you can figure out the theoretical probability. We're spinning a spinner that has 4 sections numbered 1 through 4. So our even numbers are 2 and 4, which are 2 of our numbers out of the 4 total numbers on that spinner. 2 out of 4 is equal to 50%. So our theoretical probability here is 50%. Let's go ahead and try one more. Below is a chart of jelly bean flavors pulled from a bag. What is the probability of pulling a lemon jelly bean? So if we take a look at our chart here, we pulled a lemon 4 times out of a total of, if you add those up, you get 24. So our experimental percent is 16.7. Our experimental probability is 16.7%. Go ahead and find the theoretical probability. Here we have lemon is 1 flavor out of a total of 5 possible flavors. So the probability of pulling a lemon would be 20% as a theoretical probability. Quick check. There are 52 cards in a deck. 13 are hearts. If I drew 400 times and replaced, how many times would I expect to get a heart? In this case, 13 out of 52 cards are hearts, which is equal to 0.25, or 25% of our cards. If I take that and multiply it by the 400 draws that I make, I will get a heart roughly 100 times. Remember, 13 out of 52 gave us that 0.25, or 25%, its probability of drawing a heart. So if it's 25% and we draw 400 times, you think, what is 25% of 400? 25% of 400 is 100. So what is the difference between theoretical and experimental? Again, experimental is based off of the trials that you do, and theoretical is your favorable over your total possible outcomes. If you have any questions, please send me an email. I'm happy to answer those. You guys did an awesome job today. Your homework is the Law of Large Numbers homework. Have a great rest of your day, and I'll see you when I'm back from PSSAs.